Hi, everyone. I'll be presenting the Alarm Dialog Management, or ADaM. So this project is Alarm Dialog Management is just basically an MQTT router. This project is completely software, so there's no like hardware part in it. Its goal is to manage multiple alarms and send them to multiple Krakes or annunciators or whatever thing. So this alarm management, it will have multiple functions, such as recording all interactions for post-hoc interactions, present the highest priority problem to the human responder, manage the escalation of alarm levels without allowing any needed action to be forgotten, and managing new incoming alarms conditions so they are correctly presented to the responder, and to allow alarm muting so that if there's perhaps a higher severity alarm, the operator can mute whichever annunciator they're working with so that they can focus on the higher priority alarm first, and then they can go back and check if any other alarms got in while the operator was working. This next slide it basically explains how ADaM will be working in a real life scenario. So the purpose of basically this project, people can use it in multiple industries, like let's say in a hospital or a chemical plant or a restaurant or any other things that require perhaps an alarm system. So the way it starts is that there would be perhaps sensors in whatever environment you're in, and these sensors would monitor things like temperature, or I don't know, detect smoke or something else. And once they detect something or something concerning happens, they basically send an alarm to one of the annunciators. The alarm dialog management here comes in and gets this alarm to a server, which for now we're using a public server. But if any private companies get this program from us, they would use their own private broker. So the alarm comes into the server and it gets stored, and it sends it to one of the annunciators. And this annunciator would have the description of an alarm and the alarm level. And the description of the alarm, we programmed it to be 80 characters long. And on the screen, there will be the operator will be presented with multiple options that we have programmed, which are acknowledge, dismiss, shelve, and completed. The operator will have the opportunity to basically select one of these options, and once they select the option, they send it back to the server. And the server will then either keep the alarm stored or either delete it if the operator chooses to dismiss the alarm. And all the alarms will be logged for perhaps a harm check, or if the operator wants to check status of alarms later. And they will be logged by time, date, level of severity, and the description of the alarm.
So I did want to mention one thing that Mohammed did not emphasize, which is there are, of course, alarm management systems all over the place. There's a book this one by Hollyfield and Habibi that talks about that subject. But as far as I know, there are no systematic open source alarm management systems, and certainly nothing like what we're building. And so I think we're breaking new ground with that project. And I think it's actually going to be very significant. Now, he talked about an annunciator and the fact that that was a software project. Now we're going to present the hardware component, which is the annunciator for that project. This is another team that I'm very proud of because it's very international. It's run by Naram Kir, who has grown into becoming a great leader for this team. She's in Lebanon. You're going to hear the voice of an English woman in Scotland, Courtney Luddick, on the video that they're going to have me play. It's also, there's an excellent mechanical engineer, Yahya Ayman, from Egypt, and recently a woman from India, Yakti, has joined as well. And this team is mentored by Lee Erickson. I don't know if he's here, but Lee is a really excellent mentor for those kinds of things. So I think they have a video for us to play.
The Krake is a dedicated wireless alarm device designed to inform human operators of critical conditions they need to know about, clearly, reliably, and without distraction. Krake is an annunciator, a hardware device designed to get a human's attention and inform them about a specific problem. Krake have a protocol to handle alarms and process the response of the operator. There are a variety of uses for the Krake, such as in assisted living scenarios or in pairing with other equipment, medical or industrial, or to any other machines in your residence, providing immediate alerts for events based on policies and severities that are implemented by the ADaM and by a separate ADaM project. To maximize interoperability, the Krake is designed with both API and UART connector, RJ12 and RS232, allowing Krake to be connected to equipment without Wi-Fi capabilities, acting as a peripheral device announcing the alarms of the machine it is connected to. The alarms are divided into 5 levels of severity, ranging from informational alarms to critical and emergent alarms. Krake helps deliver alarms that are timely, meaningful, and trusted when they matter most. Krake features 5 bright LEDs for visual alerts, a customizable audio system for speech and alarms, an LCD display along with a rotary encoder for simple menu navigation, and a mute button to handle the alarms, Wi-Fi network connectivity, and 2 different power options to enhance its versatility.